Hello, beautiful people, and welcome. In this video, we're going to be talking about all things unit circle, how to derive the values of a unit circle in trigonometry. As always, I am human, so if I make a mistake, please let me know where the mistake occurs, so that way I and you can learn from my mistakes. All right, let's go ahead and jump in. So what is a unit circle? A unit circle is obviously a circle with a radius of 1. So here's our circle. Pretend that's a perfect circle. A radius is from the center point to any point on that circle. So for example, here's a radius. Here's another radius from this point to this point. That's a radius. From this point to this point, that's a radius. And what's really cool about the unit circle, a unit of one thing, right, is 1. So each radius is equal to 1. Now, one thing that we recall from circles is that if your radius is 1, which is the center to any point on that circle, no matter how many lines I draw here, this radius is going to be 1. Now, what's so special about the unit circle when it comes to trigonometry? I'm going to try to draw another circle. Let's call it a perfect circle. Let's pretend that's perfect. Okay. So let's talk about the unit circle. When you see a unit circle in trigonometry, this is what you're going to be visualizing. And let's talk about our triangles. So I'm going to draw a triangle like this. And so if you recall our special triangles, special right triangles in trigonometry, we have 3 of them. We have the 45, 45, 90 triangle. We also have the 30, 60, 90 triangle. And then the 30, 60, 90 triangle also becomes the 60, 30, 90 triangle. So technically we have 2, but technically we have 3. Just depends on what angle you're looking through to see if you're looking through the 30-degree angle, if you're looking through the 60-degree angle. Okay, so let's talk about this one. Let's pretend this is the 45, 45, 90 triangle. So both of these are 45 degrees. In a unit circle, the radius is 1 unit. So that means this radius is going to be your hypotenuse. This right here is your hypotenuse. So if I'm looking through the eyeball of this specific 45 degrees, this is going to be my opposite, and this one's going to be my adjacent, because we know if it's across the street from the hypotenuse, it's going to be, if it's across the street from our 90-degree angle, it's our hypotenuse. So this is our opposite, here's our adjacent. So what do we know about adjacent, hypotenuse, and what we know about right triangle trig ratios? When we are talking about right triangle trig ratios, we know that this value here and this value here are like sine, cosine, and tangent. So let's talk about sine of theta, or in this case, 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. Now again, this is our eyeball. This is the angle that we're looking through. So, ka, toa. So means opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So what you notice is sine of 45 degrees is just the opposite value. Cosine is just the adjacent value. And tangent is the actual ratio of opposite over adjacent. And the reason this is just opposite, this is just adjacent, because of our hypotenuse. So what are these values? So let's go back to our special right triangles. And we know that for a 45, 45, 90 triangle, it follows the pattern. Just draw this out here. Make sure you guys know this is a 45, 45, 90. It follows the pattern that if we have a leg of x and a leg of x, that this is x root 2. That's the pattern. So if we want this right here to be 1, what does x have to be? So if I want this hypotenuse to equal to 1, that means my x root 2, something needs to be x in order for this to be equal to 1. So how do I equal this? So I'm going to make x, here's multiplication, so I'm going to divide by root 2. So that means x is equal to 1 over root 2. So that means that for my 45, 90 triangle, my x value is 1 over root 2, 1 over root 2. But that's weird, right? We don't like that. So this is actually root 2 over 2, and this is root 2 over 2. Now again, why does that matter? So when we're talking about the unit circle, we're going to derive these values for very specific degrees. The degrees that we're going to have is 45, 30 degrees, 60 degrees. Obviously, we have our 90. And then we continue on. We're going to derive all of these values. What is the sine of this degree? What is the cosine of this degree? What is the tangent of this degree? These values you're going to have memorized. There are tools to help you memorize these. And that's going to be in a separate video, but I'm going to show you maybe a little bit of the tricks in this video and then how to memorize it in the other one. So if you notice, let's start with the 45. If you notice, the opposite is the side, if we're looking at this angle, the opposite is the side that's going up and down. So this right here is our y value. And this adjacent is our x value. And so what did we have adjacent equal? Well, the adjacent equaled our cosine. The opposite equaled our sine. So your y value, let's say if we're talking about a point, x comma y, the y value is going to be your sine of theta. The x value is going to be your cosine of theta. So what we really have when we're talking about like unit circle and points, we have cosine of theta, comma sine of theta to make up a particular point that is going to be on our unit circle. So how does it actually look like in a unit circle? In a unit circle, it's going to look like this. So here's your radius of 1. Here's your y value or your sine. This distance right here is going to be your cosine distance. And then that's going to be your angle here. So this is your cosine of theta or your x value. This is your y or your sine value. And then you have your radius of 1. The angle you're looking through is always going to be this angle here. So looking through this angle, y is going to always be your opposite. X is always going to be your adjacent. The degree measure will depend on how you open up that angle. So your degree is obviously going to be different here versus if I have a terminal angle here or terminal ray, and it's going to be larger. So let's go ahead and start deriving these unit circles. Now the next thing I'm going to show on screen, I did not make this. This is not mine. This here, I got off of Google, so I don't take credit for it, but I think it's a really, really cool thing. What usually happens is we print out one of these and we give it to you, and that's going to be like your test or quiz. If you know quadrant 1, you know all of them. Promise you. Okay, so how do you do this? We have this line right here. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. With quadrant 1, if you memorize quadrant 1, if you know quadrant 1, I promise you, you're going to know all of them. It's super duper easy. Okay, so what do we have here? We have either circles are going to be degrees or radians are going to be boxes. It doesn't matter. So let's say our circles are going to be our radians. So if I start here, I have 0 radians or I have 2 pi radians, depending on how many revolutions. If I go nowhere, I've gone 0 radians. If I've gone 1 full revolution or 1 full circle, then I've gone 2 pi. Same thing we know here. We've gone 0 degrees or we've gone 360 degrees. We're all focused on 1 revolution. Obviously, you can do more than that. Now, if I've gone 1/4 of the circle, that means I've gone either 90 degrees counterclockwise or I've gone pi halves. If I've gone 1 full half of a revolution, that means I've gone 180 degrees or I've gone pi radians distance. If I've gone 3/4 of the way, then I've traveled, I've traveled 3 pi halves, or I've traveled 270 degrees. And then 1 full revolution is going to be our 0, 360, or 2 pi. So then what we're going to do is we're going to cut that up even more. Our very Important triangles are the 30, 60, 90 triangle, 45 triangle. So these angles, these cuts on the unit circle are going to represent our 30, 45, and 60 degrees. So we're going to start out with degrees. Let's focus on degrees first. So I have 30 degrees, 45 degrees, and 60 degrees. Let's focus on 30 degrees. This is 1/3 of the way. If I travel from our starting point 2/3 of the way, then I've gone 60 degrees. If I've gone another 30 degrees, I've gone 90. So if I travel another 30 degrees, I'm going to be traveling 120 degrees. I'm going to skip this one because this is not traveling 30 degrees. This right here is traveling a different distance. It's 45. It's not a factor of 3. So I'm going to skip this one, but I'm going to travel 30 more degrees. 30 more degrees means I'm at 150. 30 more degrees means I'm at 180. 30 more degrees, that means I'm at 210 degrees. Skipping this one because this is 45. It's not 30. Traveling 30 degrees, I'm at 240. Traveling 30 degrees, I'm at 270. Traveling 30 degrees, I'm at 300 degrees. And you kind of see the pattern here, which now I'm at 330 degrees. Now let's do 45. From our initial ray, 45 degrees is here. If I travel another 45, I'm at 90. If I travel another 45 from my 90, that means I'm at 135. If I travel 45 there, I'm at 180. If I travel another 45, that means I am at 225 degrees. Traveling another 45, and again, you see the pattern. This is 270, so this means this is, and plus 45, which is 315. So now we have all of our degrees. Let's do the same thing with radians. Radians, if I start 0, 1/4 of my circle is pi halves. So what is half of that? Let's start with our 45s this time. What is half of that? Well, half of pi halves is pi fourths. So that means my equivalent statement is 45 degrees is equivalent to pi fourths radians. Pi fourths radians is equivalent to 45 degrees. So now instead of traveling 45 degrees, I'm going to be traveling pi fourths. So here's pi fourths, here's pi fourths. So pi halves plus pi fourths, that's going to be 3 pi fourths. I'm going to travel another pi fourths. I'm going to travel another pi fourths. This is 5 pi fourths. Here I'm going to travel another pi fourths, traveling another pi fourths. This is 7 pi fourths. And we're back where we started. Now let's do the same thing for 30. The way that I like to think about 30 is kind of like opposites. If it's 30 degrees, we want the smaller angle first. So pi 6 is going to be smaller. So this is pi 6. 2 pi 6 is the same thing as saying pi thirds, and we're traveling in the distance of pi 6. Pi 6 is equivalent to 30 degrees. So pi 6, 2 pi 6, 3 pi 6. This would be 4 pi 6, or again simplify, which is 2 pi thirds. 5 pi 6. 6 pi 6 is equivalent to just pi. 7 pi 6. 8 pi 6, or 4 pi thirds. Where am I? Already 7 pi 6, 8 pi 6, 9 pi 6. Then what are we at? I think I lost myself. Let's try this. 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, which is 5 pi thirds, 11 pi 6. So you're just traveling and counting all of those distances. Okay, so now that we filled out the inside of our unit circle, let's try to see what our values are. Now, I'm just going to show you these values in class. I'm going to derive these values using our right triangle 45, 30, 90, 60 triangles. I'm going to show you what these are here so that way you can start memorizing them. This right here is a unit circle. From our center point to a point of the circle right here, this is our radius. So this line here is our radius. This line here is our radius. This line here is our radius. So we want a coordinate point, just like when we're saying 3, 2 is a coordinate point. We want a coordinate point here. Recall that the x-axis, or the horizontal line, that's going to be your cosine, The y is going to be your sine. You can also think of it as alphabet. C comes before S on the alphabet, so it's going to be cosine times sine. So if this was just a point on a regular unit, like on a regular point, here it is, and this value is 1, what would you call that point? Well, this is 1, 0, because you traveled 1, but you didn't go up or down. It's the same thing here. So this one's going to be 1, 0. Let's try this. Now I have a point on my y-intercept, and this point right here is at 1, so that means I have 0, 1. Here, similar, it's on the x-axis, however, it's on the negative side. So I have -1, 0. And here I have down below is going to be on the y, but negative side. So I have 0, -1. Remember how I said if you guys know the unit circle for quadrant 1, this right here, then you know all of it. So this is where that comes in play. Cosine of 30 degrees is √3/2. 1/2 is for sine of theta. And again, I'm just telling you these values. We already know that √2/2 is our sine and cosine of 45 degrees. We did that earlier in this video. And then what's really cool here is because we have 30 degrees, I'm going to focus on degrees right now, and then we have 60 degrees. We have the 30-60-90 triangle, and then we have the 60-30-90 triangle. You're just changing your point of view of one triangle. So these right here, they just flip. So now I have 1/2, √3/2. If you know these values, again, this is your cosine of theta, this is your sine of theta. Now, what is theta? Well, theta is 60 degrees. So this is your cosine of 60 degrees. This is your sine of 60 degrees. This is your cosine of 45 degrees. This is your sine of 45 degrees. This is your cosine of 30 degrees. This is your sine of 30 degrees. Now, why does it matter that we know just quadrant 1? Let's talk about our quadrants here. In quadrant 1, let's actually draw this out. We're pretty much done with the unit circle, I promise you guys. Let's talk about our quadrants. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, we have very specifics. That means here our x's are positive and our y's are also positive. So we have positive x's, positive y's. Here, or you can even do it like this, positive x's, positive y's. Here, in quadrant 2, what's really cool is we have negative x's, however, we have positive y's. Here in quadrant 3, we have negative x's and we have negative y's. In quadrant 4, we have positive x's and negative y's. That's the characteristics of each quadrant. So if you recall, if you remember that information, you know, what number is going to be negative, what number is going to be positive, then you're pretty much set. Let's try this. So let's see if I have enough highlighters for this. Let's start with our 30 degree. 30 degree from here. We're going to travel all the way across. The values here are going to be exactly the same for the sine and cosine, or cosine and sine of 210 degrees. However, so I literally am just going to copy these numbers. However, you have to pay attention. This is now in quadrant 3. In quadrant 3, what do we have? Quadrant 3 means we have both negatives. So I'm going to put a negative here, and I'm going to put a negative here. And you're going to just keep redoing it over and over and over. 45 here. So I have, what do I have? I have √2/2, √2/2, and then 240, this one here. That one's going to be 1/2, √3/2. Now remember, all of these in quadrant 3 are both negative. Okay, now let's see here. If you know quadrant 1, then you know all of it. These right here are going to be mirrors of each other. So if I was to take and fold on the y-axis like this, they're going to kind of like flip-flop on each other. So if this right here is 1/2 root 3 over 2, this one's going to be 1/2 root 3 over 2. This one here is root 2 over 2. This one's going to be root 2 over 2. This one's going to be root 3 over 2. This one's going to be 1/2. They're mirrors of each other. So these two match, these two match, these two match. Except we're now in quadrant 2. So what do we know about quadrant 2? Quadrant 2 means I have my x value being negative, my y values being positive. So I'm just going to put a negative on all of my x values. And guess what? We're pretty much done. These are mirrors of each other as well. So if I start out here, root 3 over 2, 1/2, this one's going to be root 3 over 2, 1/2. This one's root 2 over 2, root 2 over 2. And then this one here is, 1/2 root 3 over 2, except we're now in quadrant 4. So what do we know about quadrant 4? Quadrant 4 means my x values are positive, my y values are negative. So on my y values, I'm simply going to put a negative on there. So when I'm asking you, what is the sine of 120 degrees, all you have to do is just look here. Sine, it comes after c, so it is positive root 3 over 2. What is the ratio, right, is the cosine of 11 pi 6? 11 pi 6 is here. The cosine is the first value. It is root 3 over 2. What is the sine of pi, what is it? Let's do pi fourths. What is sine of pi fourths? Sine of pi fourths is root 2 over 2. It's the second one. And using the unit circle, you can have these values, but then you can use reference angles and you can use coterminal angles. So if I ask you what is the sine of 390 degrees, 390 degrees means I go one full revolution, I hit 360, I get another 30 degrees. So sine of 390 degrees is 1/2. You can use this unit circle. Now, you will have to memorize all the values for sine, cosine, and tangent. In the next video I'm going to post, I'm going to show you how to use that using just your left hand. It's super duper easy using your left hand. And then I recommend doing flashcards, memorizing a test. If you have a printer, print like a bunch of these and just do them over and over and over and over and over. You should know these values. All right, beautiful people, thank you for hanging in there and watching this video. I will see you in the next one, and have a great day.